Okay, assalamu alaikum. Let's begin. So, let me see if that's working. Okay, all right. Assalamu alaikum, everyone. Let's begin. So, we're doing two topics today, scatter plot and pie charts. Both of them are fairly straightforward. They're not going to take that much time. We will cover the concepts and also do some practice questions. So, scatter plots, they are also related to correlation. So, we'll also talk about correlation along with scatter plots, right? So, scatter plots and correlation. So, first of all, let's try to understand what scatter plots are. Now, this is basically a diagram in which you have two variables. Let's understand it using an example. Let's say we've got two variables, one is x and the other is y. And we've got some data points that look like this. So for instance, for x, we might have some values like this, 0, 1, 2, 3, 4, 5, 6, 7, 8. Usually there are a lot of values, right? It's a large number of values generally. Let's say we've got these 9 values, and we have some corresponding values for y, and they, let's say, look like this. 6, 6.3, 6.8, 7.0, 7.5, 8.1, 8.3, 8.6, and 9. So we've got some x values and we've got some y values. Okay. Now, scatter plot just looks like this, that you have two axes. On one axis, you've got one variable. On the other axis, you've got the other variable. So we've got x and y variables in this case. Now, since all of these values are positive, we can just represent positive numbers. We can just represent the positive parts of these axes. So let's say it looks like this. Now, let's plot these values. On the horizontal axis, we've got values from 0 to 9. So we can see we might have 1, 2, 3, 4, 5, 6, 7, 8, 9 like this on the horizontal axis. And similarly on the vertical axis, we might have some numbers like this. Let's say this is 2, 4, 6, 8, 10 like this. Okay. And now we can plot those values. At 0, we've got 6. We've got one value here, 0 and 6. And then at 1, we've got 6.3. So it'll be a number slightly bigger than that. Then at 2, we've got 6.8, again, slightly above that, slightly further above that. It might look like this at 2. So this was 1 and 6.3 roughly. You'll be doing it on a graph paper, so you can do it more exactly. You can make it more exact. So let's say this is 6.3, and then at 2, we've got 6.8. It might look like this. And then at 3, we've got 7. It might look like this. And then at 4, 7.5. At 5, we've got 8.1. At 6, 8.3. At 7, 8.6. And then at 8, we've got 9. Now, just plotting these values like this, using crosses generally, this diagram that we see here so we don't join these points with anything. We just keep it as they are. This is called a scatter plot. Okay. This figure, this is called a scatter plot. So we just plot the points, represent them with crosses like this. This figure where you have two variables, one on the x-axis, one on the y-axis, and you've got points plotted like this, and that's it. This figure is known as a scatter plot. So you just plot the points like this. Okay. Now, using these points, what we sometimes do is we draw something that we call a best fit line. Okay. We draw a best fit line using these points. Now, what is the best fit line? Let me take another random example now. So that's the idea of how to make a scatter plot. Just plot those x and y values and you get that scatter plot. But let's consider some specific variables now. In this case, we just considered x and y. What if instead of x and y, we had something that looks like this? We've got two specific variables such that on the horizontal axis, let's say, you've got the number of past papers attempted, and on the vertical axis, you've got your marks in Cambridge exams. Your marks in CAIs. So on the horizontal axis, you've got the number of past papers that you've attempted. And on the vertical axis, you've got the marks that you get in your Cambridge exams. Let's say when you plot these values, you get numbers, you get data points that look something like this. You've got 1 point here, you've got another point here, and you've got another point here, another point here, and so on. So it continues like this. You've got some data points that look like this. Okay. So you see the overall trend. The more past papers you do, the higher are the marks that you get in the exam, right? Now, this is a scatter plot, right? We've just represented those points like this. Now, if you were to draw a line through these points, we call this line a best fit line because all of these points, they're not going to fall on a single line, on a straight line, right? Because we cannot draw a line that passes through all the points. If we try to pass through some points, it will not pass through the other points. Okay, so we can't draw a line such that it passes through all the points. Now, in cases like this, what we do is we draw something that's called the line of best fit. Best fit line or the line of best fit. That's the line that we would be drawing through these points. The best fit line. Okay, now, how would that look like? It's a line that is roughly going to be passing through the middle of these points. It'll pass through the middle of these points. So you can say it's the average line of these points. Now, it might be different for different people. So you can draw multiple lines through it. It depends on how you draw it. Multiple lines could be acceptable. But the idea would be that you draw a line such that you have an even number of points roughly above the line and below the line. Okay. So for instance, if I draw a line like this, does this look like a best fit line? No, because most of the points are above the line. So it's not a very good line. If I draw a line that looks like this, is that a good best fit line? Well, we're not sure because again, we've got more points below the line, only 1 point above the line. That's this. So we want roughly the same number of points above and below the line. Okay, roughly the same number of points above and below the line. So one possible line like that could be, now it'll take a few iterations. You can try and see what works. So you'll put your scale in such a way that you have roughly the same number of points above and below the line. The line might be passing through some points. It's not necessary that it passes through all the points. It may pass through some points, and then you might have some points that are above the line and then some points that are below the line. For example, this could be one possible example of a best fit line. In this case, you see the line is passing through 2 points. This is one point, and this is another point through which the line is passing. And then I have 2 points above the line, this point and this point, and I have 2 points below the line, this point and this point. Okay. And this could be one possible best fit line through these points. Okay. Now, how do you draw this best fit line? What are some things that you need to keep in mind for this? This line is going to be kind of an average line through the points that captures the overall trend of the points. So if we look at these points, roughly the points are going in the upwards direction like this, right? So this best fit line basically captures that overall trend, that as the number of past papers attempted increases, your performance in the Cambridge exams, that also increases, right? That's the overall trend. So this line captures that trend. Now, when you are drawing this line, this is one thumb rule that you should keep in mind, that you should have roughly the same number of points, above and below the line. Roughly the same number of points above and below the line. Okay. So in this case, we had 2 points below, 2 points above, and then 2 on the line. On the line does not matter. It's not necessary that the line has to pass through a lot of points. But what does matter is that it should be roughly passing through the middle. Okay. Now, that's not the only condition that you have the same number of points above and below the line, because in that case, what if I were to draw a line that looks like this? I have 3 points above the line, 3 points below the line, right? That's not the only condition. Your line also has to capture the trend of the points. The points are going in this direction. So you can't have a line like this that has 3 points above, 3 points below, or maybe even this 3 points above, 3 points below. It has to capture the trend as well. It has to pass close to most of the points. Okay, it has to go close to most of the points. All right, that's what the line is going to look like. Now, you see the line is not passing through the origin. So if you were to extend it, it does not pass through the origin. You're not going to force it to make it pass through the origin. It's not necessary that it passes through the origin. That's another thing that you should keep in mind. It's not necessary. It's not necessary that the line passes through the origin. Now, it is possible in some cases that you draw the best fit line and it ends up passing through the origin, but it's not necessary. Okay. So these are something that you should keep in mind. Roughly the same number of points above and below the line. It does not have to be exactly the same. It's not that exactly 2 should be above, exactly 2 should be down, exactly 5 should be above, 5 should be down. But roughly the same number of points. 5 above, 6 below, right? 6 above, 7 below, something like this. Roughly this number should be equal. Okay. And that will make sure that you get a good best fit line. Okay. Don't try to pass through most of the points. That's not necessary. Just make sure that it's passing, it's going close to most of the points. That's how you draw a best fit line. Now once you've drawn a best fit line, you can use this line to do some estimation. So for example, based on this, you might be asked to predict what is the expected number of marks for a particular candidate who attempted, let's say, this number of papers. Let's say he or she attempted 20 papers. Okay. What you would do would be you would go here, look at the line that you get, and you look at the point that you get in the line, and then see on the y-axis, on the vertical axis, what's the number of marks that it represents. It might be some percentage here or some absolute marks here that you see here on the vertical axis. So maybe if for 20 you have 85 here, so would say somebody who's done 20 papers, they are expected to have 85 marks according to this particular data set. Okay, so you can do predictions like this using the best fit line. Predictions are not done using the points that are there on the diagram. It's always done using the best fit line. You'll always take points on the line for that, for making predictions. Now, once we have this scatter plot that looks like this, based on this, we can also say something about correlation between the two quantities that you have. Now, let me just erase this part. Okay, so you have a graph that looks like this. You've got certain points shown on the graphs, and this is what the trend looks like overall of the points. As the number of past papers attempted increases, you see what's happening to the number of marks. That's also increases. As you go from left to right, the graph is going in the upwards direction. This particular case, we say the correlation between these points is positive. So this is positive correlation. Okay. So these two variables, they have positive correlation with each other. Positive correlation means when one variable increases, the other also increases. Okay, they're moving in the same direction. If this increases, this also increases. That's positive correlation. All right. Let's compare that with another example. Let's say we had another data, and in this case, on the vertical axis, let's say we've got time taken. So let's say you have a car that's traveling on some highway, and on the you've got two variables of the car. One is the speed of the car, and the other is the time that it takes to go from one point to another. Now, if the speed of the car is more, it'll take less time to reach the destination, right? So let's say we are doing this for 100 cars traveling on a highway. What we do is they're going from one point to another. So they're going from point A to point B, and we are noting down the average speed at which they were traveling and the time they took to go from one point to another. Okay. Now, when we take those different data sets, different data points, and plot them here, those points might look something like this. Right? As the speed of the cars increases, what happens is the time goes down. So you see the overall trend in this data. What does the trend look like? If you were to draw a best fit line, that might look something like this. Right? Roughly, this is what the best fit line might look like. So you can see the trend as the speed increases, the time taken decreases. Okay. In a case like this, what can you say about the correlation between these quantities? If one thing increases, the other decreases, you would say this is negative correlation. So when you have a negative gradient line, negative gradient best fit line, you would say that's negative correlation. When you have a positive gradient best fit line, you would say that's positive correlation. Okay, this was positive correlation, and the one below here, that's negative correlation. Okay, but then sometimes you can end up having no correlation as well, or zero correlation. So for example, let's say you've got two quantities that don't have anything to do with each other. So for instance, on one axis, we might have, let's say, your shoe size, and on the other axis, we might have your exam score. Okay. So as shoe size of a person increases, so we have, let's say, data of 100 people, and they have different shoe sizes. If somebody has a higher shoe size, does that have any impact on their exam scores? Well, not really. So in this case, your data set might look like this. It might look like this, for instance, sometimes. You can see there's no trend, as in if the shoe size increases, the exam scores, they are not changing as such. There's no trend in the data. You would say this is zero correlation. Generally, the line of best fit in this case is going to be roughly horizontal. Okay, so this is a horizontal line. You would say this is zero correlation or no correlation. No correlation or zero correlation. Okay, so this type of data, you would say it has no correlation. Now it might look like this, even if it was the other way around. In that case as well, you would say it's zero correlation, although the gradient in that case would not be zero, but if you had data like this, again, in this case as well, there's no clear trend in the data. Right? This is also zero correlation or no correlation. Okay. And another possibility could be you might have something like this. You have two variables, and the scatter plot, let's say, looks something like this. Again, you see it's evenly distributed. It's not clear what the trend is, right? It looks like random points. There's no trend in the data. This is also no correlation. Okay, there's no correlation between the two variables, again, because there's no trend that exists. In the first two cases, there were clear trends. So this was positive correlation, this was negative correlation. And then in the last three examples, here there's no correlation or zero correlation. All right, that's the idea. That's the idea of scatter plots. It's a very simple concept. Let's have a look at some questions now. Before that, if there are any problems with this, let me know. Any questions on this? No problems? Okay, good. Let's have a look at some questions on this and see how this is going to be tested now. Okay, let's try this. We have this table that shows the times in seconds taken for each of 12 members of an athletics club to run 400 meters and 800 meters. On the grid, complete the scatter diagram. The first 6 points have been plotted for you. Okay, so we've got two sets of variables, two variables. We have 12 members in an athletics club. For each of those members, we have the time that they take to run 400 meters and the time that they take to run 800 meters. So for this one particular athlete, for example, he or she takes 49 seconds to complete 400 meters and they take 118 seconds to complete 800 meters. So on the diagram, you can see that point here, 49 and 180. This is the point that shows that 49 on the horizontal axis and 118 on the vertical axis. Okay, and similarly, you've got 6 points plotted for you on this diagram. What they want you to do now is they want you to plot the remaining 6 points first of all. Okay, so complete the scatter diagram by plotting those remaining 6 points. So we've got 56 and 129. 56 and 129. So on the horizontal axis, you see 2 units represent 1 unit. On the horizontal axis, 2 units represent 1 unit. On the vertical axis, 1 unit represents 1 unit. So be careful about that. So this is 129 and this was 56. 56 and 129. Let's mark that point. That will be here. You make a cross at this point like this, such that the point of intersection of the two lines, it's on that specific point. Okay, so that's what this point looks like, 55, 56 and 129. Similarly, you've got the other point, 63, 138. 63, 138. That will be this point here. And then you have 50 and 126. That would be here. 61 and 131. That is going to be here. Right, this is 61. And then 53, that's this. 53 and 119, that would be this point here. And then finally 55 and 127. 55 and 127, that is here. So we plotted the rest of those points. This is what the points look like. Okay, you'll do this using a pencil. Okay, you always draw diagrams using pencils. This is what the scatter plot looks like. That's the first part. They wanted you to complete this diagram first of all. Okay, so we've done that. Now it says, runners who took less than 55 seconds to run 400 meters and less than 125 seconds to run 800 meters are selected to enter an athletics competition. How many of these runners are selected for the competition? How many runners are selected? Now, what's the condition? They should have taken less than 55 seconds to run 400 meters. So they should be to the left of 55. Okay. Less than 55. And at the same time, there's an and. Less than 125 to run 800 meters on the vertical axis. Less than 125. So on this diagram, you can basically spot the points in which both the number on the horizontal axis is less than 55 and the number on the vertical axis is less than 125. So to the left of this line and below this line, what are the points? These are the 4 points that you've got. So how many points do we have here? We've got 4 points. Let's write that here. There are 4 runners who would be selected for the competition that satisfy both of these conditions. Okay. Let's move on. What type of correlation does the scatter diagram show? Now, there are three different types of correlation that we've done: positive correlation, negative correlation, and no correlation. Now, you can see as you go right on the diagram, the points are going in the upwards direction, right? So there's an upwards trend here. So this is positive correlation. So you'll say the correlation is positive in this case. All right. Now it says draw a line of best fit on the scatter diagram, the best fit line, the line of best fit. How do you do that? It should capture the trend of the points. So overall, they're going in the upwards direction. And then you should have roughly the same number of points above and below the line. And the line should be close to most of the points. Okay, now let's try a few lines and see if they work. So I could draw something like this. Okay, so this is what we might start with. Okay, so we've got 5-6 points above the line, 5-6 points below the line. However, this line is closer to the points that are above, right? And it's more away from the points that are below, right? So the points that are below the line, they have more distance from the line, and the points that are above the line, they're closer to the line. That means it's not going to be very accurate. Let's bring it down a bit. Let's say we do something like this. Does that make more sense? Okay, now you've got 4 points here, 6 points here. So you've got 5 points below, 7 points above. Okay. Let's try to make it slightly better. Now, you see, the problem that we're having here is we've got 2 points that are very far away from the line. Generally, when we draw scatter plots, if there are extreme values like this, if there are outliers like this, so these points are very far away from the line, right? So from the rest of the trend that you see in these points, these two specific points, they are quite further away from the line. In problems like these, in graphs like this, what you should try to do is just focus on the rest of the points. Focus on the rest of the points that are relatively closer to each other and ignore those points. Okay, one of those points is going to be above the line, the other is going to be below the line. That's going to be the case. However, when you're thinking about drawing the line, you just focus on the rest of the points, and it might look something like this. You see this particular line. Now, it's passing through 2 points here. It has 4 points in this region, 4 points in this region, 1 point here, 1 point here. So we've got the same number of points above and below the line. There are 2 points that are falling on the line, and it roughly looks like capturing the trend in the points that we've got. Okay, so this is one possible best fit line that you could draw. Keeping in mind the conditions that we discussed earlier, it should capture the trend of the points. There should be roughly the same number of points above and below the line. And we should not care about the outliers. Okay. We ignore them and just focus on the rest of the points. All right. Now, what about the next one? It says another runner took 65 seconds to run 400 meters. Now, on the horizontal axis, you've got time to run 400 meters, right? That's the horizontal axis. They've not written it down for you here. Let's just do that. This is time for 400 meters on the horizontal axis. They're saying another runner took 65 seconds to run 400 meters. Use your line of best fit to estimate how long they would take to run 800 meters. So on your graph, what you can do now is you can look at the point where you have 65 on the horizontal axis. That's this point. Go to your line and see what does that represent on the vertical axis. On the vertical axis, it's close to 135 seconds. So you can say for this particular point, 65 on the horizontal axis. The number on the vertical axis is 135. So the runner who took 65 seconds to run 400 meters, we expect him to take 135 seconds for the 800-meter race from our line of best fit. And that's what you write down there. That's the result that we've got. Okay, that's 135 seconds. So that's how you make these scatter plots and also use the line of best fit to make some estimates like this and also figure out whether the correlation is positive or negative. Okay, that's the simple idea. Now the other problems, you will see that they all look pretty much the same. So that's it on scatter plots. Let's move on to pie charts now. That's the other thing that we want to do. Pie charts. Okay, now what are pie charts? Let's try to understand that using this example. So let's say we've done some survey from some families. So how many families do we have in total here? 12, 6, 3, 9. If we add up all of these numbers, that is 18 plus 12, that's 30 in total. So we've done a survey from 30 families, survey of 30 families. And each of those families was asked what is their favorite pet. Okay. Or maybe what pet they have at their home. So 12 of them said they have a dog. 6 of them said that they have a cat. 3 have birds and 9 have no pets. Okay. Or 12 of them said that their favorite pet is a dog. 6 said that it's a cat. 3 said it's a bird. And then 9 said that they don't like pets. Okay. Now you want to represent this information in the form of a pie chart. You want to represent this information in the form of a pie chart. Now, what does a pie chart look like? It's basically a diagram in which you have a circle and the values that you have, they're represented using angles. So for this particular table, the pie chart would look something like this. Let me make a circle first of all. Just give me a second. Yeah. Okay, so this is what a circle looks like here. We would want to represent this information on this pie chart. Now, how exactly can we do this? We would have the center of the circle somewhere. What's the total angle in a pie chart? The total angle in a pie chart is always 360 degrees, right? Total angle of a circle. What's that? That's 360 degrees. So this complete angle would be 360. What we want to do is we want to represent each of these numbers, each of these categories using an angle on this pie chart. Now, how would we do that? The way to find the angle that would represent each category is that we can use a formula like this. We can say angle of a particular category, it's going to be x over the total number. So x represents this number, whatever that number is, divided by the total numbers. In this case, that's 30 times 360. So when you have to draw a pie chart, then you can use the formula like this. So for example, we have these values. We want to figure out what angle would represent each of these values. The total angle in a circle is 360 degrees. What would 12 represent? What angle would 12 represent? We can say 12 over 30 times 360, right? So it's basically using ratios. 30 represents 360 degrees, what would 12 represent? We can use this formula for this. We will also see how to use ratios for the same thing when we do some questions. 12 over 30 into 360, what does that give you? This gives you 144. So the angle that would represent dogs on this pie chart is 144 degrees. Do the same thing for the rest of them. For this, you do 6 over 30 into 360. What does that give you? That gives you 72 degrees. For this, again, 3 over 30 into 360, that will be 36 degrees. For this, you do 9 over 30 into 360. And that is going to be 108 degrees. These are the different angles that we're getting. Now, all we have to do is represent these angles on this pie chart. Now, how do we start? Generally, you would see in the questions that they have in the exam, they will give you some starting point. So they might give you a horizontal line here to start from, or sometimes a vertical line to start from. And then you start measuring angle from there. If they have not given anything like that, then you draw your own line. So you start from anywhere, it doesn't matter. So you can draw, for example, a horizontal line first, or any line, and then you start measuring angle from there. So for example, this might be the first line that we have, let's say. Now, you would put your protector here. This is how the protector is going to be placed here. This will be the 0 on the protector. Okay, this point here. And you would measure angle like this. So first of all, let's measure this angle 144 degrees and see where that is. It might end up being somewhere around here, such that this angle is 144 degrees. Okay. And you would write down dog here, that 144 degrees here on your diagram represents dog. Okay. And then for cat, you have 72 degrees. That might look something like this. This angle is there. It's 72 degrees. How would you measure this? You would place your protector like this now. So when you've drawn the previous line, you would rotate your paper and place your protector like this. Rotate the paper and place a protector like this, such that it's this shape. Okay, that's how you place a protector with 0 again on the origin, and you start measuring angle from this side. And you measure 72 degrees from there. That will give you this. Okay. And now the next angle is 36. What do you do now? You place your protector here. This is what it would look like, with the center of that on the center of the circle. And you start measuring angle from here, and you measure 36 degrees now. Okay. You measure 36 degrees. Where is 36 going to be? You might end up getting okay. When you measure 36 from there, you might end up getting something like this. So such that this angle is 36 degrees. 72 represented cat, and then this represents bird. And then the remaining angle, it would automatically be that remaining angle, which is 108. And that is going to represent that last category, which was no pet. And this is what your pie chart looks like. Okay, so that's the idea of a pie chart. You represent each category using an angle like this, and then you just label the pie chart, label each region like this. Okay, so that's the idea. That's how we make the pie charts. Now that's a very straightforward one, in which you have all the data given, and you just have to make the pie chart. Now, mostly what happens is they have some values missing in the data and the questions that they give. And you have to find those missing values either using the pie chart or doing some calculations. Okay, let's take some examples for that, try to understand how that would work. Remember a few things. The total angle is supposed to be 360 degrees in a full circle. And this is how we do these calculations for the angles. X over 360, X over total times 360. Now, this is what we use when we have all the data given. Then for finding angles, we can use this formula. All right. However, when we have some data missing in the question, and we have to find that missing data, using ratios is a much better idea. And that is what we would do in some questions that we practice now. Let's have a look at some questions. So we have a gym that has 4 different types of machines. Okay, I seem to have disconnected on my other device. Can you please confirm if you can still hear me clearly? And also, okay, was there any lag at some point? Did I get disconnected or anything? Okay, all right, thank you. Okay, let's have a look at some questions now to understand how we would be using that now. So we have this gym that has 4 different types of machines. Now this person, Carol, is going to draw a pie chart to show how many times machines are used in one day. She has started to make a table. Okay, so she has made a table like this. The first column represents the machine that she is using. So there are 4 different types of machines. And then the number of times each machine is used is given here. 90, 75, 57, and the last data point is missing. And we also know the angle that represents that machine on the pie chart. 120 degrees, 64 degrees, and so on. Now, using this, we have to, first of all, complete this table. Now, how can we do that? How can we complete this table? Let's think about this. Now, here we can use ratios. So you see, 90 degrees represents 120 degrees. So 90, the number 90, frequency of 90, that represents 120 degrees on the pie chart. What should 75 represent? Now, rather than using that formula, x over the total times 360, it will be much more efficient to use ratios here instead. Okay, so what we can do is we can do something like this. 90 corresponds to 120 degrees. 90 corresponds to 120 degrees. What should 75 correspond to? Let's call this x. Okay. And using this, now we can make an equation. 90 over 75, that should equal 120 over x. So we make an equation like this. 90 over 75 equals 120 over x using ratios. Cross multiply, and that gives you 90x equal to 75 times 120. This is from the calculator paper. So we can just put this on a calculator and see what that gives us. 75 into 120 divided by 90. The value of x turns out to be 100. So this angle here is supposed to be 100 degrees. Okay, so we've got this angle 100. Now, what about 57? We could either use the ratio method again here to find this angle, but it's much easier to do it directly because we've got 3 angles known now. We have just one angle missing. What's the total angle in a circle? It's 360 degrees. So to find that remaining angle, what we could do is we could say, let's do 360 minus the remaining angles, 120, 100, and 64. And you can see what that number turns out to be. It would be 140 minus 64. That's 76, I think. So this should turn out to be 76. Okay, let's just confirm that. 360 minus 120 minus 100 minus 64, that is 76 degrees. That's this angle that we have. And now we have to find the weight for this. What do we do now? Again, we could use ratios. Let's call this number something. Let's call this y. And again, you can say 57 represents 76. What should y represent? Okay. Or you can use any other row. For example, you can say 75 represents 100. What should y represent? What should y be? Right? 90 is 120 degrees. What should 64 degrees be? Right? Use any of them. I think with the 100 one, the calculation will become easier. So I'll just use that. You can use any of them. You could say 75 represents 100 degrees. What should be the value of y here if it's represented by 64 degrees? Again, we can make an equation. We can say 75 over y, that equals 100 over 64. So we make an equation like this. Cross multiply. 64 times 75. That equals 100 times y. And you can see what that turns out to be. 75 into 64 divided by 100. And that's giving me 48. So the value of y therefore is 48. So this number in the table, we can say that is 48. And that completes our table. Okay. So in order to find missing values in the data, it's much easier and much more efficient to use the ratios instead. Okay. And now they're saying complete this pie chart. How do we do that? We've got two sections on the pie chart given already. We've got the weights. Weights is represented by 64 degrees. So we can say this angle is 64. Let's label that angle. This is 64 degrees. And then running, that's 120 degrees. So this angle is supposed to be 120 degrees. You want to represent the other two now, rowing and cycling. Now, how do we do that? You can start from anywhere, it doesn't matter. After running, you have rowing here. Let's start with that. How do we represent rowing? One idea is that we place our protector on this line. Okay. So when you extend it, it would look like this. Just make it narrower. You basically place your protector like this. You can remember it's not a straight line. So this line on the pie chart and this line on the pie chart, they're not straight, okay? Because this angle is more than 180. So it's not a straight line. So when you place your protector, make sure that the protector is aligned with this part of the line, okay? It should be aligned with this part. And then what you do is you measure angle. So your protector is going to look like this side. You measure angle from this side. And what angle do you measure? 100 degrees. Let's do that. So you'll place a protector like that, like I explained. You measure 100 degrees from that, and that would look something like this. Okay, so you'll do it by measuring the angle properly. This will turn out to be 100 degrees, and then the remaining angle, what's that? The remaining angle is 76. So we label this as 76, and then we label those categories as well, label those regions as well. 76 degrees is cycling, so we write cycling here. And 100 degrees is rowing, so we write rowing in this region, and that completes this pie chart. Okay, that's what it looks like. Let's do another example. Let's try this one. The pie chart summarizes the results of a local election. The candidate B received 600 votes. Okay, so we know that this candidate, this received 1600 votes. Work out the number of people who voted in the election. The total number of people who voted in the election, that's what you want to figure out. Okay, now how do we think about this? 60 degrees represents 600 people, right? We want to find the total number. Total number means all of these. What's the total angle in a circle? The total angle is 360 degrees. What should 360 degrees represent? That's what we're looking for. Okay, 60 degrees represents 1600. What does 360 degrees represent? Let's say it represents x. We can make an equation like this: 60 over 360, that equals 1600 over x. Cross multiply, and that gives us 60x equals 360 into 1600. And that should give us the value of x. You can see what that is. 360 times 1600 divided by 60. And that's giving me 9600. So the total number of people who voted, that's 9600. Okay, that's the first part. Now it says, what fraction of the vote did candidate D receive? Give your answer in its lowest terms. What fraction of votes did candidate D receive? Now you see, this is 144 degrees. This is 60 degrees. This is 90 degrees on the diagram, right? What about the remaining angle? Can we find that? We can say 360 minus 144 minus 60 minus 90. What does that give us? 360 minus 144 minus 60 minus 90, and that's giving me 66 degrees. Okay, so this angle is 66 degrees. That's the angle, but we were not asked for the angle. We're asked for the what fraction of vote did D receive? So D received 66 out of 360. So if you look at proportion, D is represented by 66 degrees. What's the total angle? That's 360. This is going to give us that fraction, 66 over 360. Just put this on your calculator directly and it will simplify it. Again, why? Because it's the calculator paper. You can do it on your calculator directly. Just put this like this, 66 over 360, and see what that gives you. That's 11 over 60. So you have to represent it in its lowest terms. It's 11 over 60 like this. That's the final result. Okay, now it says how many more votes did A, how many more votes candidate A did? No, how many more votes than candidate A did candidate C receive? So candidate C received more votes as compared to candidate A. How many more votes? That is what we want to figure out. Okay, now how do we think about this? One idea could be that you could find the number of votes for candidate C separately, number of votes for candidate A separately, right? That's one possibility. The other possibility is to just find it directly. How would you do it directly? You could say, the difference between the angles is what? 144 minus 90, right? So we want to find the difference between the votes received by both of them, right? We can say we're looking for difference, right? The difference, 144 minus 90, what's that? That is 54 degrees, right? 144 minus 90. What is that number going to be? Given that we know For example, that 60 degrees represents 1600. So we know what angle represents what number. So 60 degrees represents 1600. Or we could say 360 represents 9600, right? You can use any of those, and that should work. And that gives your ratio. You can say 54 over 60 divided by x over 1600. That should give you the value of 54 over 60 equal to x over 1600. That should give you the value for x. You can see what that is. 54 times 100, that equals 60 times x. You can see what that value of x turns out to be. That's 5400 divided by 60. So candidate C received 90 more votes as compared to candidate A. We write 90 here because the difference between the angles is 54 degrees. 54 degrees corresponds to, okay, there's something wrong with this. I'm sorry. I put the wrong number. It's a very small number. It can't be that. I wrote 100 instead of 1600 here by mistake. I correct that. That's supposed to be 54 into 1600. Let's put that. 54 into 1600 divided by 60. And that's 1440. That makes more sense. This is 1440. So we knew that 60 degrees represented 1600. The difference between those two is 54 degrees. What should that represent? That represents 1440. Okay. Now, how did I spot that error? I wrote 90 there earlier, right? So I thought, okay, 60 degrees represents 1600. How can 54 degrees represent only 90? That's too much of a difference. So that made me think I've done something wrong. So I just corrected that. This is how you would do these calculations. Okay. Any questions on this? Any problems? No problems? Okay. Let me see if I can find a more difficult one. They're all pretty straightforward, most of them. Okay, let's just try this one last question, and then we end. In a survey, some students were asked which of these three pictures labeled X, Y, and Z they preferred. The results are represented in this pie chart. Calculate the percentage of students who preferred X. Okay, percentage of students who preferred X. How do you figure that out? X is preferred by students represented by angle 216 degrees. What's the total? The total is 360. So we can say 216 divided by 360. What's the percentage for this? You just multiply it by 100%, and you can see what that is. 216 divided by 360 times 100, and that's 60%. Okay, yeah, good. Find in its simplest form the ratio of the number of students who preferred X to those who preferred Y. Give an answer in the form M ratio N. Ratio of the number of students who preferred X to those who preferred Y. Now, how do you find this? 216 degrees, 296 degrees. Put this in fraction form. 216 over 96, right? That's the ratio. You can put this in your calculator directly and then convert it to the other form. 216 over 96. Let's see what your calculator gives. It gives you for this. 216 over 96. That's simplifying to 9 over 4. They want you to write down the ratio in this form, M ratio N. Remember, ratios can also be written like fractions. So that's why we were using fractions there. And now we write down the final answer. We say that's 9 ratio 4. That's the ratio that we were looking for. Now it says, given that 44 students preferred Y, that means this number here is supposed to be 44. calculate the number of students who took part in the survey. That means the total number of students. That is what we are looking for. How do we think about this? 44 is represented by 96 degrees, right? We want to find the total number. The total is represented by 360. We can find the value of x from this. Again, just use ratios, make a fraction out of this. 44 over x should equal 96 over 360. Cross multiply and you get 44 into 360. That equals 96 times x. You can see what that turns out to be. 44 into 360 divided by 96, and that gives you the result. That's 165. That's the total number of students who took part in the survey. Okay, I'll just do one more part. I think I saw that here. Which talks about the difference. Yeah, I think this one. Okay, let's just do this one last question, then we end. The number of children whose favorite color is red is 75 degrees. So you can see that here. We've got some children and we have their favorite colors represented in the form of a pie chart. Find the number of children in the group, given that the number of children whose favorite color is red is 75. So this number is 75. The angle is 90 degrees. We can say 90 degrees represents 75. What's the number of children in the group? What's the total number of people? Total number of children, 360 degrees. What should that represent? Okay, so you can just use ratios again to find the value of x. This is going to turn out to be, you can try that, 300. This number is going to be 300. So, okay, so you can make a fraction like this. You can say 90 over 360 equals 75 over x. That will give you x equal to 300. Okay, now it says find in its simplest form the fraction of children whose favorite color is green. Now, green is represented by an angle of 30 degrees. The total is 360. So 30 over 360, that will give you 1 over 12. That's this fraction. Okay, fairly straightforward. Let's focus on this one now. How many more children answered yellow than answered blue? How many more children answered yellow than answered blue? Now for yellow, we've got 108 degrees. For blue, we've got 78 degrees. Let's find that the difference between the angles first. 108 minus 78, and that gives us 30 degrees. That's the difference. We want to find the number of children represented by 30 degrees. How can we do that? We can use any number that's given already. We know that 75 is represented by 90 degrees, for instance. So we can say 90 degrees represents 75 children. How much should 30 degrees represent? You can also do it mentally if you want. This should end up being 25. If you want to do it formally, you'll make a fraction like this. 90 over 30, that equals 75 over x, and the value of x turns out to be 25 from this. And that's what we were looking for. That's how many more children answered yellow as compared to the ones who answered blue. The difference between the angles was 30 degrees. 30 degrees represents 25 children. So that's our final result. Okay. Any problems? Any questions on this? All right, that's it then for today. So we covered pie charts and scatter plots. Now in the next class, we'll do 2 more topics. On Thursday, inshallah, we'll do 2 more of the smaller ones. But that's it for today. I'll see you again on Thursday, inshallah. Allah Hafiz.